Hello and welcome. We are glad that you have joined us. My name is Marco Estrada, and I'm a technical trainer specializing in Microsoft Azure infrastructure and security. I'm here to walk you through the AZ-700 course, Design and Implement Microsoft Azure Network Solutions. In this session, we'll cover the design and implementation of network security. In this video, we are going to learn how to build practical Azure security mindset by using Microsoft Defender for Cloud recommendation, plus hands-on protection controls like Azure DDoS protection, Azure Firewall, Web Application Firewall, and network security groups. You will also learn configuration concepts and then apply them in hands-on exercises. Let's get started. In this section, we are going to talk about implement Azure Network Security. We're going to learn what is the Microsoft Cloud Security Benchmark, use the Regulatory Compliance Dashboard, and then we are going to talk about DDoS or Distributed Denial of Service, some attack strategies, and choose the right protection tier. The Microsoft Cloud Security Benchmark, it is a collection of high-impact security best practices and recommendations. It will provide you a single control framework to meet the security controls across cloud. So that means that it not only works with Azure, but it also will work with other cloud provider vendors. It will give you a consistent user experience for monitoring and enforcing multi-cloud security benchmark. It will use Defender for Cloud in the Azure portal to streamline the process with a regulatory compliance dashboard. It aligns with industry standards like the Center for Internet Security, or CIS, the National Institute of Standards and Technology, NIST, and the Payment Card Industry, or PCI. When you're working with the Regulatory Compliance Dashboard, one of the things that you're going to notice is that you have different regulations to choose from. So make sure that you're selecting the Microsoft Cloud Security Benchmark, or previously known as the Azure Security Benchmark. Check that your subscription is selected and start using the network security control. Remember that we might have other security controls in it, but since this is a network training, we're going to focus only on the network security one. And then take a look at the recommendations. There is going to be a lot of things that you might want to, fix in order to increase your security posture. And then you can also review how many of the instances that you have in your environment are compliant with it. In the previous slide, we learned about what are the different proactive things that we can do in our environment to make it more secure. But there are some times that we are going to, need to review also the reactive ones. Defender for Cloud will tell us when there is a problem within our network by generating an alert, and then probably we need to take care of that as soon as possible. There are other tools within Defender for Cloud that we can use, like the Cloud Security Explorer or the Attack Path Analysis, which are not shown in this slide, that will help us identify the most urgent, externable, initiated, and exploitable threats. Let me quickly change the subject and talk to you about DDoS attack strategies. There are three main attack types, and Azure provides us with the DDoS protection service to help us prevent these attacks. The first type is the volumetric attack. It will flood your bandwidth with massive amounts of network traffic. The idea behind this attack is to make your application unresponsive. So what DDoS will do will automatically absorb and scrub the attack. The second type, the protocol attack. It will exploit the weaknesses in the network and transport protocols, targeting network devices and protocol stacks. DDoS will differentiate between your legitimate and malicious traffic to block the second one. The third one is the application layer. So it will target your application packets. So basically, it will target your web applications and servers. So this type of attack can be combined with Web Application Firewall so DDoS can do its job better. The first thing that you need to think about is that whether you want to protect a group of public IPs or just individual ones. If you have multiple public IPs, well, you can create a DDoS protection plan. With this plan, you can protect up to 100 public IPs. If you decide to just go for one specific public IP, for example, attached to an Azure load balancer, you can do that as well within the public IP itself. Now let's create a DDoS protection plan and enable the protection for a specific virtual network. In this demo, we're going to create a DDoS protection plan for network protection. We are at the Network Security Blade, and here we're going to create directly from the overview page. Just like any other Azure resource, we need to define the resource group that we're going to use. In this case, will be courses, and we're going to call it DDoS plan for our environment. The region we are going to use is West Europe as the other resources. Independently of what region we are going to select, we can add or apply to all my resources in multiple subscriptions. Let's just review and create a plan. Once it is created, we can just go to the resource to associate the virtual network where my resources are located. If you remember, we have a hub virtual network where we have multiple public IPs that we can protect, and that's what we're going to do next. We need to go to Add Protected Resources, and it takes us to the Settings page. In here, you'll see the different protected resources that we can have. We need to add my virtual network. I have my virtual network hub that will be one of my virtual networks, and after that, I will add the spoke networks as well. Once it's done, let's add the second spoke network. We can just wait a little bit just to see that the spoke network appears under virtual networks. If you don't want to wait, we can just click on a different tab to see if we already are protecting different resources. In this case, the application gateway, this is the public IP. I don't have a bastion host, but I have a load balancer on public IP 3, so we have network interfaces for my virtual machine 0. We also have the virtual network gateway that I created for VPN. That will be the public IPs 1 and 2, and that's pretty much it. So that's the things that I have in my environment now. So I'm already protected just by adding these virtual networks. Let's go back to the presentation. In this section, we're going to talk about how to design and implement Azure Firewall. We're going to describe what it is, how to deploy the firewall in a hub-spoke topology, what is the Azure Firewall Manager, how to manage your policies, and the rule processing order in Azure Firewall. Azure Firewall is just like any other firewall. It would sit between your trusted and untrusted networks. It will analyze the incoming connections going through it, or maybe the outbound connections going to the internet, for example. It is useful for your internal communications, the east to west type of communications, or from the internet into your internal network. By default, the firewall will deny any access to your network, so you will need to create some rules to make that happen. In a previous video, we talked about the hub and spoke topology. So the idea is that the Azure Firewall will sit on your hub network with other services that are also centralized there, like the Virtual Network Gateway or Azure Bastion. Then it will allow the communication between your spoke networks. So that's where you have your databases and your application servers. And remember, you will need to change the system routes by using a user-defined route so you can send all the traffic to your Azure Firewall. One thing that might happen to you is that you will have multiple Azure Firewall instances. Whether you are deploying them into the hub network or maybe you have a secure virtual hub, you will need to manage at scale. So that's why we have the Azure Firewall Manager that will help us centralize this management. When you're working with multiple Azure firewalls, you also need to use multiple policies to allow or deny the traffic. So there's certain rules that you need to take into consideration while working with these policies. As you probably noticed in the previous slide, we could have parent policies and child policies. So you need to make sure that how the ordering takes place. Remember, parent policies always take precedence. Then, within the policy, you have rule collection groups, which are processed in their priority order. Within those groups, you have rule collections that are also processed in their priority order. And within those rule collections, you'll have DNAT, network, and then application rules are processed in that specific order. So let's talk about this specific type of rules. The DNAT rules will manage inbound traffic through one or more firewall public IP addresses. So we are going to use it to translate a public IP address into a private one. Then we have the network type of rule, which it will control both inbound and outbound, just like east-west traffic based on the network layer, which is the layer 3 on the OSI model, and the transport layer, which is the layer 4. You will use a network rule to filter traffic between IP addresses, ports, and protocols. And last but not least, you have the application rules. These will be for outbound and east-west traffic based on the application layer, or layer 7. Use this type of rule to filter traffic based on fully qualified domain names, or FQDNs, URLs, and HTTP, HTTPS protocols. Now let's deploy an Azure Firewall, create a policy, and play around the rules. In this demo, we're going to create an Azure Firewall. Here we are again at the Network Security blade, and we're going to click Create under Azure Firewall. We're going to select the course's resource group, and we're going to name the firewall just Azure Firewall in here. We are going to use the West Europe region to select later on the virtual network where we create the subnets for this one. In this case, it is recommended me to use the premium SKU. We already seen the differences between basic, standard, and premium. In my specific case, I will go with the standard. For the firewall management, we can use a firewall policy to manage the firewall, or I can use the rules embedded on the firewall, which is a classic way to do it. So for example, for basic and premium, the firewall policy is the default. I'm going to use the firewall policy because I want to show you later how to configure rules on that policy. We are going to call it Azure Firewall Standard Policy. And also I'm going to add West Europe as my region. We are going to use the existing virtual hub network because we already have different subnets already created for us in here. We don't have more public IP addresses because we just run out of them. Remember that we have one for virtual machine 0, then a couple for the gateway, and then one for the public load balancer. So basically we're out of public IPs. Nevertheless, I can create one in here. We are going to call it Azure Firewall Public IP, for example, and I'm going to create one now. And then later we have the management NIC to separate the traffic that you're going to use for managing purposes from the customer traffic. In this case, this management NIC also needs public IPs, so we are going to create a new one. We are going to use Azure Firewall Management Public IP in here. We now have 2 new public IPs, and that's pretty much it for the creation of the firewall. We're going to wait a little bit until the firewall is deployed, and after it's done, we're going to take a look at the policy for configuring the different rules. Once the deployment is complete, we can go to the resource to take a look at, for example, the private IP of the Azure firewall. We can take a look also to the public IP and the management IP. We don't see them directly in here, but we can just click through it and copy that public IP because later we're going to use it to test some of this. Other things that we're going to review is that the firewall policy it is created. So far, the firewall policy does not have any rules. We need to define those rules as we saw in the presentation. We have DNAT rules, network rules, and application rules. For the purposes of our exercise, we're going to create a DNAT rule. First and foremost, we need to create a rule collection because we don't have one so far. We are going to call it DNAT collection, and it's going to have a priority of 1000. In this specific case, we are going to save it with the default DNAT rule collection group. What we're going to do, just like we did in a previous demo, we're going to do a DNAT for a virtual machine. I think it was virtual machine 1. So now we are going to do a DNAT for virtual machine 2. We need to know what is going to be the source of this request. So the source can come from anywhere. We are going to choose the protocol TCP. The destination port in this case, let's use the same like we did on the load balancer. And the destination IP will be the firewall IP that we just copied from, and that is going to be translated to the private IP of the virtual machine 2. In this case, the private IP, as far as I recall, it is going to be 10.1.1.4, and we're going to translate the port 3389. That's going to be the configuration. We are going to add that and wait a little bit until that configuration is applied to the firewall. Once the configuration has been updated, you're going to see the rule that is going to appear in the firewall policy so we can test it out. Let's go to our remote desktop configuration. We're going to paste the public IP of the Azure firewall and the port we selected to configure it. Let's try that, and we're able to connect. What it means is that from my public IP, I'm connecting to the Azure firewall, and from there, the Azure firewall is generating a new connection through my virtual machine 2 in this case. Let's take a closer look so we can review the actual IP address that we are using. Let me make this a little bit larger. Let's use netstat for reviewing where the connection is coming from. In this case, we're going to find the string that relates to the port 3389. With this, we're going to see that the connection is going to my virtual machine 10114, and the source of the connection, or what I'm using, is the Azure Firewall internal IP, which is 10.0.1.5. If we do the same, for example, for the virtual machine that we created the NAT configuration with the load balancer, we are going to see something slightly different. Why? Because in this case, the Azure Firewall is generating the connection itself, whereas the load balancer, the configuration is passing through. So what that means is that we're connecting from the public IP that I'm using to establish this connection. And with that, we finish this demo. Let's go back to the presentation. In this section, we're going to talk about design and implement Web Application Firewall. We're going to talk about what it is, what is the implication to use Web Application Firewall within Application Gateway and Front Door, and we are going to talk about the default rule and the use of custom rules. One thing that you need to take into consideration is that Web Application Firewall works together with either the Azure Application Gateway or the Azure Front Door. It will provide you with centralized protection for your web apps from common threats like SQL injection or cross-site scripting. So the idea is that you use the default rule set that the Microsoft security team creates, maintains, and updates, and that is better than patching each individual web application. Before you start running the Web Application Firewall, you need to create a policy and then later associate it to your, in this case, Azure Application Gateway. You can either associate it to the whole gateway, or maybe you want to associate it to a specific listener, or maybe to a specific path-based rule. Azure Front Door is no different from Azure Application Gateway. You still need to create a policy, and that policy needs to be associated to one of your Front Door listeners. So what is different though is that when you're using Front Door Premium, you can use some custom rules or not only the managed rules, whereas in the Front Door Standard, you are only going to use the managed default rules. Talking about the default rule set, it is worth remembering that we have a pre-configured rule set and that also you can bring your own type of rules by using the user-defined rules. Web Application Firewall works in two different modes. The default mode, which is the detection mode, will log the request that is coming to either your application gateway or front door, but will allow the request to go through. Whereas the prevention mode will log the request, but it will not allow the request to go through if it is an attack. In the case of custom rules, you first need to define their priority, and then you need to select the type of rule that you want to use. You can, for example, have a match rule that will control access based on a set of matching conditions like location, IP address, or size. And there is also a rate limit rule that will control access based on matching conditions and the rates of incoming requests. Then you need to decide what you want to do with that request. You can either allow it or deny it. In this section, we are going to talk about implement and manage network security groups, or NSGs. We're going to learn about what they are, what are the different rules that we can implement, what the service tags or application security groups are, and how to monitor and troubleshoot the network security groups. During this video, we have talked about how to protect our perimeter network. We talk about DDoS, firewall, or web application firewall. But now it's time to secure our virtual networks. And that's where NSGs come into play. The idea behind NSGs is to protect either the inbound connections or outbound connections coming out from the virtual network, and it is associated either to the subnet or at the network interface level. With one NSG, we can associate multiple subnets or multiple NICs at the same time. At the NSG level, you're going to see that we have some default rules, both for inbound and outbound connections. These rules cannot be deleted, cannot be changed, but we can override these rules by creating higher priority rules for either inbound or outbound connections. For your custom rules, you can specify the source and destination details like IP and port, and also protocol. You can choose from many pre-configured services like SMTP, RDP, HTTP, or you can create your own custom rules. Remember, rules are processed in the priority order, and from there is no more processing for that specific rule. So what I'm trying to say here is that when you define a rule in that specific place, and then we match that rule, we don't take a look on the rest of the rules now. The lower the number you have, the higher the priority. There are limits on the number of rules you have for each Azure location and subscription, so make sure that you take a look at these limitations. Sometimes when you are creating your custom rules, you will need a helping hand. So what I mean by that is that you don't need to know all the different public IP addresses that we have in Azure. So instead of that, you can use service tags. So the idea behind service tag is that you can select either a specific service like, well, Azure Storage or Web Apps, or even adding a specific region within that specific service. And then you can select it either in the inbound or the outbound connection as well. Just like service tags, there's sometimes that you need to group together virtual machines by either application or workload. And instead of writing down all their IP addresses, you can use application security groups instead. So the idea behind the ASGs is that are on the same region and subscription as the virtual machines that you are going to group together. ASGs can be the source or destination in a security rule, just like service tags. In case you want to monitor or troubleshoot your NSG rules, there are a couple of tools that you can use from the Network Watcher. First, you have the effective rules that it is going to give you an aggregated view of the inbound and outbound rules applied to a specific network interface card. And the second one is NSG diagnostics. It will help you verify that your NSG rules are set up properly. And also take a look at the video about network monitoring that is ahead on this training course. Now let's see how to create an NSG, how we're going to associate it to a specific subnet, and how to configure inbound or outbound rules. In this demo, we're going to create a network security group, and then we're going to associate it to a specific subnet. We start at the virtual network overview. We can either go to network security groups or just scroll down a little bit more, and under security, we can just click create. We are going to use the same resource group, and we're going to name it the VNet Hub Network Security Group. We need to choose the same region as we created the virtual network. In this case, it was West Europe, and we're going to review it and create. After the resource has been created, now we can go to the resource and then do the association. But before, let's take a quick look at the inbound default security rules that we saw on the presentation. These are the different inbound default security rules, and also you have the outbound security rules. What we need to do now is to associate it to a specific subnet. We are going to select the default subnet that we created before. We are going to click OK in this case. Now we are going to have that network security group applied to that specific one. In this case, we can also add new inbound security rules. For example, if you want to add my public IP address to connect directly to any destination, or maybe anything inside my virtual network, I'm going to choose either service tag for the virtual network, or I can define a specific IP address within my virtual network, or an application security group that we just learned on the presentation. The service that I'm going to use to publish in this case, it is going to be RDP, because I want to connect to one of the virtual machines through this protocol, and I'm just going to allow it and set a specific priority. I'm going to name it as allow RDP to my VNet. And with that, we are creating an inbound security rule which will allow RDP connections. This is the port, the protocol, the source, and the destination. Let's go back to the presentation. In the demo, you saw that I created an NSG rule to allow the communication to my virtual machine using the port 3389 or RDP. If you're like me, you probably don't feel comfortable of doing that through the internet. That's why Azure provides us with a service called Azure Bastion that we can use to connect to the virtual machines that you have inside your virtual network. So what you need to do is that you need to create an Azure Bastion resource, which will need to have a dedicated subnet. And from there, you can connect using the Azure portal. Then it will give you the connection to your virtual machines. If it's a Windows machine, will connect you through RDP or remote desktop protocol, or there's a Linux machine, it is going to connect you through SSH. And remember, all this connectivity, it is secure. You can think of it as a jump server as a service. This concludes our session. Please review the following slides to remember some of the topics touched in this video. Pause the video now and read carefully some of the Azure Network Security services that we reviewed today. There are many ways to continue your learning journey. We encourage you to watch other videos in this course or maybe search out for your next favorite topic on Microsoft Learn at aka.ms/learn.